Hello there, it's me, once again following a day of pain and suffering. Today I spent, let me put it this way, wasted the entire day trying to do one stupid, simple little thing. And I believe that thing that I was trying to do is impossible given the way that this operating system is organized. And that has to do with palettes. I remember I've talked about palettes, right? And there's this create div section. Now in this project, I know I'm going to have to deal with palettes because all GIF files have palettes, okay? And so do these things have palettes too. So, but anyway, just as a simple test, I changed this paletted bitmap to a 24-bit, it's 24, true color almost, bitmap to see if I could display a picture on the window. Sure enough, it displayed. Okay, no problem. Now all I gotta do is make that happen with this bitmap. Same picture, just got a palette. That's all, just display the picture, please. Oh, and now on and on and on. Here's some of the history of what I was looking through to try and get it to work. One thing is that you can, if you're a genius, you can figure out how to create a log palette. I'm just really not that smart. And then you can realize it. Realize the palette into your HDC. Okay. Now they recommend that you should use the system palette entries, for speed. System palette. Read this. Get system palette entries. What does that mean? Let me remind you that in the year 2013, once again, properties, personalize, screen resolution, advanced, monitor, 32 bits, 16 bits, and I can't scroll up any further. I can't get to 8 bits or anything less than 16 bits with a modern monitor. In fact, they don't even make them anymore. That is to say that there are no paletted modes on this computer or any modern computer today. So what's a system palette and why should I even give a damn about it? I don't know. Now create div section was failure. Complete failure. I tried this, setting the thing in div pal colors, right? What does that give me out? It gives me another pointer to some memory. And what is that point? Pointers that receives the DIB bit values, okay. And now where does it say? Oh yes, okay. Either if I select div pal colors, then the BMI colors array member of the bitmap info structure, blah blah blah, is either a logical palette, which is impossible to make, or indices to literal RGB values, which is what I have. And these things are defined. But no, I don't have literal RGB values. First, I have a palette of literal RGB values. So what I have to do is div pal color, so therefore I need logical palette indices, and then I'm not able to fill up this does not give me a pointer to an area to put color values in. This tells me where I can set the palette entries in for my HDC. You understand what I'm saying? I don't want a palette. The file has a palette. I don't want a palette. Okay. Well, I wonder what a log palette is. Well, there's pal version undefined. If you do a search, you'll find that 0x300 is the correct number to put there. Then palette entries, a number of entries, and then an array of palette entries. So this is like a file, a kind of file that is just a palette. Okay, well that's no good. Then I found this create DI bitmap. Now this sounded promising. Now see if you can set this FDW init thing here, and this thing is supposed to fill in the values and everything all in one shot. So I tried setting that to true, and I got a little bit of the picture, but it was mostly black and white, and with some little shades of blue here and there. No good. But then it said, setting that value to FDW init is equivalent to calling create compatible bitmap for the, to create a DDB, a device dependent bitmap in the format of the device. Remember, my device is a 2-color bitmap. That's what we start with. And then set DI bits. Well, I tried that and I got a black and white bitmap. So that didn't work either. So that flag was no good. And now it's got a info header, bitmap data, and then color format data. Now this is a bitmap info color format data. What the hell is it? An array of bytes containing initial bitmap data depends on the BI count member of the info structure. Well, basically it's saying both these pointers are the same. Well, I tried setting them the same, and none of that worked either. Then I tried this set DI bits, which has you need an H-bit map first in order. So you got to create a bitmap again using div pal colors, which again requires a logical palette. But applications can receive the system palette colors and indices by calling get system palette entries, and then we can find a closest match to the blah 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 blah. Finally, I gave up. Forget this thing. Onto the internet. Create logical palette from bitmap. Trying to just figure out how to make a logical palette. Maybe I can select it in the device. And I click on some of these things. There's only one example in the whole world, apparently. And this is not it. See, they always start out with this kind of text. Trying to figure out how to implement palette support can be quite a messy process. The documentation that exists is never entirely clear on what approach one should take. Loading directly, blah, 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 blah. Palette change. When am I going to get a palette change message? There's no palette. I don't want to realize any palette. You see, I used to program computer games. So I know what a palette is, okay? Basically, all a palette is, all a file with a palette amounts to is a file with a little compression algorithm. Instead of 3 bytes per color, you use 1. And it's got a lookup table for the colors. But in the old days, you see, a palette used to be a part of the hardware. That's why in this PC View Mode 13 thing, you see things like, I even wrote this out in assembler. Suppose you want to set the color value for index 5 of the palette in mode 13, okay? Now you take port 3C7 and send a 5 out to it. Now you read in from 3C9 3 values consecutively, red, green, and blue. Now I made a mistake and I took them as 5-bit color values, but in fact it's 6 bits. Which is a very odd thing. I don't know how you can have 6-bit color value, but that's the way it is. Similarly, to overwrite a palette entry, you enable the writing mode of the physical device, and then you outport first to C8, which tells it you're ready to write something, and then 3 bytes out to 3C9 to set the red, green, and blue values for palette index number 5. You see, this is part of the hardware. And so the Windows GDI interface is based on this hardware view, where a palette is an integral part of the device, right? But that's obviously not the way I'm looking at it. Saying, okay, look, here's a file, right? It uses this funny compression algorithm that has a color table, and the color table is mapped to red, green, and blue values. And I would just, like to load it up and draw it like I do with my other bitmaps, using those colors as indicated by the compression algorithm. If you can do a PNG or JPEG with even more complex algorithms than that, why not a bitmap? I mean, why not a paletted thing? And the reason is because they don't think that way. That it's not in their brain. Like it's remember when I talked about one function bullying another and asking it to do the impossible, and a simple enough problem, unsolvable because one thing is asking another thing to do the impossible. And that's in this case the Windows graphics device interface being the bully and asking me to do the impossible, to try and fit a square peg through a round hole. Finally, I figured out that the answer, there's only one answer, right? Which is you don't use a palette ever, right? You never ever use any palettes. What you do is you take this file and you do like any rational human being would do. You go through the color table and you extract the red, green, and blue values and create a true color bitmap and put it on the screen. Now I happen to do that by creating a new file. I could have done it all in memory, but instead I already had the code for a file, so I invented create true color bitmap, which puts it in a temp file, and then I construct from file. But I should do it in memory because I still have to deal with the resource case. And so then that meant that I had to I have no file support in any of this. I add all sorts of file support, checking if things exist, temp files, and blah, blah, blah. And great big horrific mess. Horrific mess. And the answer, of course, though being simple enough, it involves, for me anyway, a lot of work, because I've got to make sure that when I add these file type functions that they're going to work correctly, right? For one thing, now I need a current directory function. So I gotta make sure that works properly. Then I got to take care of this fact that if it's an NTFS volume, you have to call the wide character versions of everything, and you got to pretend this funny thing. That means you've got to find out the path name, the long path name, and then checking for existence is another problem. This is still not fully implemented. File size works, and somewhere at the bottom here, I didn't know where to put it, is my converting thing. I've taken care of one case, which is the only case that anybody ever uses anyway, where it's an 8-bit palette, and I convert an 8-bit bitmap to a, well, see, now I was setting it to 24 bits, bits per pixel 24, like that picture here. See, it's 24 bits, but I recall that when we were doing computer games, there's something to do with the scan lines always having to end up on D-word boundaries. Now that's not something that the programmer would have to worry about. But you get better speed if you bump this up to 32 bits, so I decided to put it to 32 bits. I mean, again, look at the video resolution. That says 32 bits. Why does it say 32 bits when there are 3 colors, red, green, and blue, and 1 byte per color? What's the extra byte for? Nothing, right? It's just there for alignment because it aligns better. So a 32-bit bitmap will blit faster to the screen. Hardware will deal with it faster than a 24-bit thing. It's got to, fiddle around and put padding here and there. And who cares about the file size, right? Memories cost nothing, zero. The amount of hard drive space available is infinite, right? So you don't care about this extra bit. And so, but anyway, so now the next problem. The next problem is to implement all these functions. Now, see, he's doing this set palette thing. Now, this is easy to set the palette entries. Right? All I do is I invent output blah 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 thing, right? And I make a color table, right? 256 value color table, taking 6-bit red, green, and blue values, right, which I would convert to 8 bits. Even though he's taking them from 8 bits and converting them to 6, and I'll convert it back to 8. And then now when he wants to change the palette, all I'll do is change the values in the color table and invalidate rect, and it'll draw. Plot pixel here takes a position X, Y, and an index into a color table. Now I know how to deal with a color table. That's how this thing works. This is working. You'll notice the program. Oh, it's not in here. It's in here. Where was the file name? Where am I loading the file name? Here. wlogo32.vmp, which is not you. Okay. Paletted. There it is. Paletted. It's actually turned into a 32-bit bitmap. And it goes into some temporary directory. I don't need this anymore. I'm basically doing what I was doing before with the horse, right? Instead of loading up PaintShop Pro and converting things to 24 bits, which should be 32 anyway, I'll do that dynamically. I'll get rid of the temp file, do it in memory instead. Then that leaves just this problem of the GIF. The GIF is you see here. Now this thing's got a whole bunch of palettes in it. Here's the bit, okay, that he's ignoring. There's a global color map. And I'm not worried about any of these color maps. That's just that's just mapping an index to a color. Then local mother color map follows use pixel. Then there's sequential or interlaced format. Now that's the part of the complicated bit of these things. Interlaced drawing is they had a picture of it somewhere. What's so great about it being interlaced? This here, pass 1, pass 2. Yeah. You see, it's the local color map thing. It's quite. It doesn't look like it's a simple. It doesn't look simple. It looks like a lot of work to figure out how to locate what color goes where. None of this, and it's also compressed, right? Using this LZW compression, which, by the way, even though this starts out saying that you better be careful, you might get sued. According to Wikipedia, all the relevant patents have expired. So, you're allowed to use LZW compression, without having to pay a royalty to someone. Even so, they don't all use the same compression algorithm, so that's another problem. So yeah, it's quite a mess. These GIF files. It's hard to tell what's going on. Raster. I don't even know what this raster means. I've seen it everywhere. That was a sophisticated algorithm based on blah blah blah. You can do decompress and display at the same time. Well, now see that, but now while that was locked up in someone's um, uh, patent, the PNG format was invented. It does the same thing. So everyone switched to PNG because you don't pay a royalty. So, so some of these GIFs apparently are PNG compressed. That's okay. I got code for decompressing PNG. I don't know about LZW. There's a lot of work. And nobody seems to have written any code. Well, there is that stuff I downloaded, so maybe I certainly don't want to figure out that how that compression algorithm works. It's like finding out like a better way to compute pi. I get the idea. I don't need to know any more specific. Okay, well, anyway, at least I can do a paletted bitmap. Maybe I'll move on to JPEG and take it from there. Alright, see you.